Now let's have a discussion about potential energy of a dipole in an external field. Now we have many a times have discussed about dipole. Dipoles are two charges of opposite, that is opposite charge, that is if it is plus it is minus, and this is separated by a distance of twice a, where a is very small. So this can be considered as a dipole. Now we know that in a given electric field, we have already discussed, in a given electric field, the dipole experiences a torque. Torque tau is given by dipole moment into the electric field E. So this is dipole moment in the electric field, which we have already derived in our previous video. So now, by carrying this over here, say suppose let this be the two charges, this be Q1 and this be Q2. So there is a torque. So there is a rotational motion that has been generated, but there is no translational motion. So a rotational motion about the center of a dipole has been generated. Now this is the distance A and this is the distance A. So initially, let's say this is the direction of the electric field. So let this make an angle of theta with the dipole. Now because of this electric field, it experiences a torque, and because there is a change in direction. Now change in direction from, say suppose this is initially, this was say theta 1. Later on, because of the torque, it rotates about its dipole center and comes in this particular direction. Say this is Q1, this is Q2, and let this angle be theta 2. Therefore, now there is a displacement because of a force. Displacement because of a force, that is, if there is a displacement because of a force, then there is work done. Then we can say that there is work done. So we can say because of the tau, that is because of this tau, this torque, there is a displacement of d theta. There is a displacement of d theta. And therefore, this work done is given by, from theta 1 to theta 2, that is final position is theta 2, initial position is theta 1, is nothing but tau, which is external, this is the external electric field, into theta into d theta. Now tau is nothing but Pe sin theta. Now this is a function of tau with respect to theta. Now what is tau? Tau was Pe theta, which is equal to P dipole moment. Now P is dipole moment. Pe, this is cross product, P cross E, therefore Pe sine of theta. From here we have Pe sine of theta. So your W becomes integration from theta 1 to theta 2, dipole moment P into E into sine of theta into d theta. Now if I integrate this sine theta from theta 1 to theta 2, I will have, I'm writing this over here, this part of my calculation from this part. Therefore work done is actually equal to dipole moment into electric field, magnitude of dipole moment into magnitude of electric field, into cos of theta minus that is the position, that is there is a change in position. Now please keep in mind, if you integrate sine theta, you will have minus. So the dipole moment is actually from minus of theta 2 into theta 1. Now taking this minus, now in your book this minus is actually final position of theta 2 minus initial position of theta 1 with a minus, because integration of sine theta will give me minus cos of theta, and differentiation of minus cos theta will give me sine theta. So that is why integration of sine theta gives you minus cos of theta. Therefore in your book straight away you have been given this particular formula, but if you look at one step, it is easier to understand. This is minus, this is PE, integration of sine theta is minus PE cos of theta. This is minus PE cos of theta from theta 1 to theta 2. This becomes theta 2 minus theta 1. Now again, taking inside the minus, you have PE cos of theta 1 minus cos of theta 2. So this is what you can understand. Now say suppose if you can say that if this is the initial position, now when will the work done be maximum? When this value, when theta 1 is maximum. When theta 1 is maximum, the work done will be maximum. So in a way we can say that when it starts from theta that is equals to 0 to theta equals to pi by 2. When theta equals 0 to theta equals to pi by 2, we have the work to be maximum. That is because PE cos of theta 1 is cos 0 degree minus cos pi by 2, which is nothing but P into E. Work done is dipole moment into electric field when there is a complete rotation. That is when initially the dipole moment was over here and it becomes dipole moment is something like this. At this point there is a maximum amount of work that has been done. So this is how you can understand dipole moment in an external electric field.